All right, so now I want to introduce to you the first trick or the first innovation, and it's called a difference network. Now, the tricks I'm going to teach you, they are not foolproof. Neural networks are very fussy, okay? You need a lot of experience before you can really start to get results. So a lot of people give up. I know a lot of people say, look, neural networks are not for me. I measure use some XGBoost or some stuff like that. And that's probably true. I think for casual problems and so on, the XGBoost and tree-based systems are idiot-proof, and they allow you to focus more on the data manipulation part, etc. Right? But neural networks will give you the bang for your buck, honestly, when it comes to forecasting, because oftentimes you get a better lag, a lower lag compared to decision trees. Okay, and there's a lot of knobs and tricks that you can use to actually hammer your networks where it gives you a good result. So the first trick I'm going to teach you is called the difference network. So this is the first thing you can do. And the idea is that you got your past data, but you take out the y naught, the y(t + 0), right? And this, by y, I mean the label you're trying to forecast for, but at t + 0. Okay, you don't include it in as input necessarily, okay? Or at least you separate it out. Okay, so then what you have is you have your past data and you pass it through your feed-forward network as usual, but you add the output of your network with the y naught, okay? And this becomes your forecast. All right, and this simple change can actually make a big difference for a lot of problems. Certainly, we have seen a lot of improvement in anything with cyclic, like demand forecasting, etc., or where the input data isn't so noisy. This is actually just a fantastic job. Just this one change alone. Okay, so why? Because it oftentimes gets you a network that almost instantly beats persistence. So just now, the naive network happened to beat persistence as well, but it's by no means guaranteed, believe me, okay? There's also very little need. I wouldn't say no need for detrending. I would say little need for detrending because you're taking differences. So even if you go up by a constant value, for example, then there's no need to really detrend. Spikes are okay, all right, because they are transitory as well, and you're looking at the differences, which are much smaller than the spikes. And because you are forecasting dy rather than the y value itself, you typically get more labels, more examples that the network can learn from. And that's the reason really why we want to use this. There's just so many good things, okay? So I'll give a demo of the difference network. I won't run it through this time. I'll just give you the results. So this is the difference network, okay? All right, so if you recall, you see at least there is some learning here in the first part before it starts to flatline and then it gets chopped off by early stopping, right? So this part here brings that error rate down to, I think, 0.49, okay, which is actually pretty good. It's not too well, it's not too shabby. It's much lower than persistence, okay? And all we did was just to add that term on your network. Okay. Right, so we add the y naught here to the output of the network before we compare it against the y. And the Euclidean loss is just RMSE. Okay. All right. And as my input, what I did was I did a difference. So I have the A5, which is my labels. 5 weeks ahead. I have my y naught here. I selected y naught as the second column, okay? And I've added, I've got those 20 columns, but I take a difference. Okay, so the difference I've set it up to be 5 steps. In other words, T0 minus T5, T1 minus T6, etc., and so on, okay? That's how I do the difference. Okay, that's it. All right, and you can see that the results I get are actually pretty good, right? So previously the naive was 0.57. When I did it on live just now, I got 0.61, and now the difference gives me 0.49, which is actually a substantial improvement. Okay, And if I go to my predictions, let's just see what happens here. Okay, you can see also that the training is a bit better. It's a bit fuller than before. And the forecast is also a lot better, or at least it looks like it, okay, visually. That's for testing. This is for this is for training, and this is for testing. Let me just shrink this down a bit. Okay, now this lag graph tells the truth. So you've got a peak here at t+0. The blue is for training and the red for testing. I've got a peak here at t+0 for the train, a major peak. But I'm also getting a minor peak at the t+5. Okay, and that's really because I'm using dropouts. So the more dropouts you use, you'd find that your training becomes your training peak becomes lower and lower, less overtrained, and it reverts to the y0, which this blue line goes, the blue peak goes up at persistence. Now my test, unfortunately, is still very peaky at persistence t+5. Okay, but I'm beginning to see some semblance of a hump here. You can see it, okay, at a t+0. Okay, and our goal really is to try and grow this peak while keeping the RMSE down, and let's see if we can do that. Okay,